This represents a building that has 3 fairly massive floors, and then the uprights represent the steel columns of an actual building. An earthquake would tend to shake a building sideways. It would tend to make the ground move like this, and depending upon the frequency content of the earthquake, one or more of the modes of vibration could be excited. This one has 3 clearly distinct modes of vibration, the lowest being when the entire building sways from side to side like this. Then the next higher one would be when the top mass moves one way, the bottom mass moves in the opposite direction, and the center mass is relatively stationary. We can approximate these starting conditions just by striking the top mass and the bottom mass. And this frequency is somewhat higher than the fundamental frequency. It's impossible to isolate the higher modes from the lower modes completely, but the highest mode then would be when the center mass moves to my left and the top mass and the bottom mass move to my right, and we can approximate this by striking the center mass. And that is again a higher frequency than the second. So if we then use some arbitrary starting condition, we can probably excite all 3 of them at the same time, which gives a very complex motion. And one would notice that the bottom floor looks like it stops and then restarts, and this is just because we are adding 3 different sine waves together, and so there will be an effect of beating. And this mass does stop, whereas the others will take turns in stopping. It's a very complex waveform, but it's made up of 3 sinusoidal frequencies that are not necessarily multiples of one another.